In this video, we're going to be talking about solving equations that have radical signs in them. Before we start though, let's just review. Let's say we're solving an equation that has a square, and a variable squared, x squared equals 9. So the inverse operation of squaring is taking a square root. So take the square root of this side, and you also take the square root of this side. And so we have x is equal to plus or minus 3. Remember, when we solve by taking square roots, we have to write plus or minus, and that's because the original equation was x squared equals 9, 3 squared will equal 9, and negative 3 quantity squared equals 9. So there are two values that x could be. Here we have a cube root, so the inverse operation, or we have x cubed. The inverse is the cube root, so we take the cube root of both sides. So x equals, now here we're saying, what is the value that if you cube it will give you a negative 8? Well, there's only one value that's true with it, would be negative 2. And then the cube root of 12,167, you can either put that in your calculator, or you can look at your chart of cubes and find that number, and the cube root would be 23. So when we're solving equations that have radicals, the first thing we want to do is isolate the radical term. So this has a plus 3. So first we're going to subtract 3 from both sides. So we have the square root of 2x minus 3 equals 5. We want to get, the x is inside the square root, so we have to get rid of the square root. Opposite of taking the square root is squaring, and if you square one side, you have to square the other. So then on this side, we have 2x minus 3, and then 5 squared is 25, and then we can solve for x and divide by 2, so x equals 14. And if you substitute that back in, you'll see that it works. 3 plus the square root of 2 times 14 minus 3. 3 plus the square root of that would be 28 minus 3 is 25, which is 3 plus 5, and sure enough, that equals 8. Okay, here's another one. Let's get the square root by itself. So first we add 5 to both sides. So you have the square root of 4x plus 1 equals 5. Square both sides, get rid of the square root. So we have 4x plus 1 equals 25. And get the variable term by itself. And lastly, we get the variable by itself. 4 is getting multiplied by x, so we're going to divide by 4. And so we have x equals 6. Now here we have a rational exponent. And remember, that symbolizes, or is the same as the cube root of x plus 1 quantity squared. So what we're going to do is rewrite this in root form. It can be done using the exponent, but we're going to stick with working with the radicals. So we're just rewriting this. Now, going back to what we did before, first we want to isolate the radical term, or the variable term, which happens to be a radical term. So we have the cube root of x plus 1 quantity squared equals 4. First thing we want to do now is get rid of the root. So this is a cube root, so we're going to cube both sides. So then you have x plus 1 quantity squared still is equal to 4 times 4 times 4, which is 64. Now we have the term squared, so we're going to take the square root of both sides. Remember, when we take the square root of both sides, we have to write plus or minus, and the square root of 64 is 8. Subtract 1. We have x equals negative 1, and then plus or minus 8. That means you have two answers. You have negative 1 plus 8 and negative 1 minus 8. So that would be 7 and negative 9. Those are the two answers we have, and they will both work if you substitute that back in. Let's do another one. So first, we want to isolate the term that has the variable. So we're going to get rid of the plus 1 on both sides. And then we're working to isolate this term, so it's getting multiplied by 3, so we're going to divide by 3. And now this is a fifth root. The opposite of taking the fifth root is raising to the fifth power, and you have to do the same to both sides. So then we have x plus 1 quantity cubed equals 8 to the fifth power, which is a very big number. It is 8 to the fifth is 32,768. And then we're going to take the cube root of both sides to get rid of the cubed. So then we have x plus 1 equals, I even need my calculator for that. So on the calculator, we're going to type in 3 second function cubed root of 32,768, and you get 32. And then we'll subtract 1 from both sides. So x equals 31. Next, what are the solutions of 2 times this quantity to the 2/3 power minus 8? So let's rewrite that in root form. So this number, remember, goes in as the index. All right, so first thing we're going to do is isolate the term that has the variable, so we're going to divide by 2. So we have cubed root of x plus 3 quantity squared equals 4. Get rid of the cubed root, so we cube both sides. 4 times 4 times 4 is 64. And take the square root of both sides. So we have x plus 3 equals plus or minus 8. Subtract 3. X equals minus 3 plus or minus 8. So that would be minus 3 plus 8, minus 3 minus 8. So that's 5 and negative 11. All right, now we're going to do a problem, and you'll notice this time we have an x on both sides. And so it says check your results, because sometimes when we have an x on both sides, we can get what are called extraneous solutions. They're solutions that come out when we're doing our math, but they don't actually work when you substitute them back in. So the first thing we want to do is get the root by itself. So we have x plus 7, and we're going to add 5 to both sides. That equals x plus 5. Now, we're going to square this side to get rid of the square root, but we also have to square the other side, which means the whole entire side. So you need to put parentheses around it. Don't forget that. That's huge. So then we have x plus 7 on the left. This means x plus 5 quantity squared. So you have to write x plus 5 times x plus 5. And we will have to FOIL that. We are squaring a sum, so you have to write that sum twice. So that would be x squared, so we FOIL, plus 5x is 10x plus 25. And this is quadratic because it has an x squared. So when we solve quadratics, we need to get everything on one side. So we're going to subtract x from both sides. And we're going to subtract 7 from both sides. So we will end up with 0 on the left, and then x squared plus 9x plus 18 on the right. And then to solve, we can either use a quadratic formula or, when possible, factor. That will be quicker. So factors of 18 would be 6 and 3. Those are the ones that add up to 9. And then, if you'll recall, we set each of those factors equal to 0. So x equals negative 6, and a negative 3. And then we need to substitute that back in to our original equation. So that was x plus square root of x plus 7 minus 5, and see if that equals x. So when we substitute in a negative 6, that'd be negative 6 plus 7 minus 5. And we want to know, does that equal a negative 6? So this is 1. The square root of 1 is 1 minus 5. That does not equal a negative 6. So this did not work. Let's try substituting in a negative 3. So wherever there's an x, we're putting in a negative 3. So that would be 4. The square root of 4 is 2. And that does work. Negative 3 equals negative 3. So the answer there is negative 3. Let's do another. Now this one, you see we have 2 radicals going on. And we could just FOIL right away. But I think you're going to find that it's easier if you take the one that is the most complex, get that one by itself. So we have square root of 2x plus 1 equals 1 plus the square root of x. We're going to bring this one to the other side. So now we square both sides. So here you have 2x plus 1. And here we have a sum, so we have to write it twice. So you have 2x plus 1. Here you have first, it would be 1. And then when we FOIL, the outer is plus 1 square root x. 1 times the square root of x is 1 square root x. And then you have the square root of x times the square root of x, which is the square root of x squared, which is just x. Let's just combine like terms here first. So 1 plus x plus 1 root x, and 1 root x would be 2 root x. Now, we have another square root going on, so we need to isolate that. So we're going to subtract everything from that side. So this gives us 1x equals 2 root x. Now at this point you could divide by 2, but it actually is fine if you just square both sides. So this gives you x squared on the left. Here we're squaring the product, which means we have to square both parts. So 2 squared is 4. The square root of x squared is x. So now we need to bring everything to one side because it's quadratic. And you could do the quadratic formula. Your a would be 1, your b would be negative 4, the c would be 0, or this is one where you can factor an x out of both terms. So you would have x minus 4. X squared, if you take out an x, you have x. 4x divided out an x, you have just 4. And then we set each of those equal to 0. X equals 0, so you take this factor set equal to 0. X minus 4 equals 0. Take this factor set equal to 0. So x equals 0 and x equals 4. Again, you need to substitute those back in. So if we had 2 times 0 plus 1 minus the square root of 0, does that equal 1? So that would be 0 plus 1. So the square root of 1 is 1 minus 0, that equals 1. Yes, the 0 works. Now we'll substitute in the 4. 2 times 4 plus 1 minus the square root of 4. Does that equal 1? So 2 times 4 is 8 plus 1 is 9. Square root of 9 is 3. Square root of 4 is 2. And that works as well. So in this case, you have both answers. All right, and there's some practice there you can do. Let me know if you have questions. Thanks for watching.